Welcome back to The Explainer. Okay, let's jump straight into this because things are getting wild. On August 14th, 2026, Alibaba dropped Qwen3.8-27B. And, the AI community just completely lost its mind. We're talking massive, wall-to-wall internet hype about a frontier-level 27 billion parameter model that can supposedly turn your everyday consumer hardware into an elite AI workstation. But, whenever we see hype spreading like wildfire like this, we've got to take a step back and separate the marketing from the actual physics.
So let me pose this central question directly to you. Can an 18 gigabyte file packed with 27 billion parameters really truly run smoothly on your standard laptop? We're looking at this fascinating dichotomy right now between what developers claim is totally possible and what your hardware can physically handle without melting down.
Because on one hand, you've got these viral posts out there celebrating 41 tokens per second on a $400 RX 9060 XT GPU. Just pure excitement, right? But then you've got developer Burke Holland. He ran this exact same thing on a massive 64 gigabyte setup and literally called it, quote, slow. Rip if you have to compact, not a consumer-grade local model, pointing out he was barely scraping by at 18 tokens per second. So how on earth can both of these realities exist at the exact same time?
Well, to find out, here's our roadmap for today. First, we're going to meet Qwen3.8-27B. Then, we'll bust the laptop myth, find the hardware sweet spot, explore thinking modes and speed, and finally, deliver the local AI verdict. We are going to methodically cut right through the noise to find out what actually works.
All right, let's kick things off with Section 1. Meet Qwen3.8-27B, defining the beast and establish exactly what Alibaba just unleashed on the world. Now, the absolutely crucial thing to wrap our heads around here is what a dense model actually is. Unlike a mixture of experts model, where only a tiny little subset of parameters activates at any given time, a dense model means all 27 billion parameters are firing all at once for every single token it generates. Because of that heavy lifting, it completely starves standard consumer hardware of memory bandwidth. It is intensely bandwidth bound. And while its 64-layer hybrid architecture might mirror the older Qwen 3.6, do not let that familiar structure fool you. This thing is a serious agent candidate. We are talking native vision and text understanding, a massive 262,144 token native context window, and the whole shebang is totally open under an Apache 2.0 license. It's an incredibly capable model, but yeah, that capability demands some serious resources. Which brings us right to Section 2, the laptop myth, anatomy of a hardware trap. It's time to do a little reality check on the dream of squeezing this beast onto your everyday computer. 16 gigabytes. I really want that number to sink in for a second, because that heavily advertised 262,000 token context window, it's kind of a trap if you aren't prepared for it. Utilizing that full context window requires 16 gigabytes of memory just for the attention KV cache at BF16 precision. That is a massive chunk of space completely gone before you even load the model weights, let alone open a single Chrome tab. And this exact hardware trap is why laptop naming conventions are, honestly, super misleading. Think about it. A desktop RTX 5090 gives you 32 gigs of VRAM and a blistering 1792 gigabytes per second of bandwidth. But the laptop version of the RTX 5090? That only gives you 24 gigs of VRAM and literally half the memory bandwidth at 896 gigabytes per second. They might share the exact same name, but they are absolutely not the same product when it comes to running local AI. So what actually happens if you try to run this beast on a 12 gigabyte laptop using heavy RAM offloading? Well, technically, sure, it runs, but you are going to be crawling along at a painful 3 to 4 tokens per second. Your GPU basically holds what it can, and the rest just spills over into your much slower system memory. It becomes a test of absolute patience, not a practical workflow. Moving right along to Section 3, finding the sweet spot, what you actually need. Instead of struggling with those slow speeds, let's look at the data-driven guide to the hardware that actually gives this model room to breathe. The absolute secret to unlocking this model's potential is understanding the memory ladder. Take the highly recommended dynamic Q4 format, for instance. The file itself is roughly 17.9 gigabytes, but in reality, you actually need 24 to 32 gigabytes of total system memory. You absolutely need that extra headroom for the context cache we just talked about, plus whatever your operating system is eating up. It's the same story for the lightning-fast NVP4 format on Blackwell hardware. You still need that 24 to 32 gigabyte sweet spot to run smoothly.
Now, if you're out there looking to buy hardware specifically for this, the data points to a pretty clear winner for the smartest purchase: the M4 Pro Mac Mini with 48 gigabytes of unified memory. You see, Apple Silicon allows its GPU to access that massive shared pool of unified memory, and the M4 Pro boasts 273 gigabytes per second of bandwidth. This setup literally lets you run high-fidelity quantizations, handle image inputs, and use those massive contexts without breaking a single sweat. It's a game changer.
Okay, let's shift into section 4, thinking, modes, and speed, community wins. Because we really have to celebrate how insanely fast the open source community optimized this model right after it dropped.
Remember just a minute ago how we said dense models are supposed to be notoriously slow on Macs? Well, within mere hours of release, the MLX.fast community launched a challenge and implemented multi-token prediction and speculative decoding. And they managed to increase Apple Silicon speeds by a staggering 153 to 170% over the baseline. They completely shattered the whole belief that Macs are just inherently too slow for this type of architecture.
But look, if you want absolute face-melting speed, the desktop GPU is still undeniably the king. Developers using SGLang and NVIDIA's new Blackwell NVFP4 quantization format achieved over 200 tokens per second on a single desktop RTX 5090. That is elite, data center level speed, just running quietly right there under someone's desk. Absolutely wild. Which brings us down to our final section. Section 5, the local AI verdict. Getting started. Let's summarize everything and give you a quick step-by-step roadmap for deployment. If you want the most functional, completely frustration-free way to get Qwen3.8-27B running locally today, just follow these steps. First, go ahead and download the Unsloth desktop app. Second, select the dynamic Q4 quantization. Third, and this is important, force yourself to set an 8,000 token initial context limit. Do not just jump straight to 262K. And fourth, test your performance right there first, making sure your system can handle it before you slowly start to expand that context window. Now, something you really need to know is that Qwen3.8 defaults to maximum thinking straight out of the box. You've got to tame it a bit. You'll want to use a temperature of 1.0 for thinking mode, but actually drop it down to 0.7 if you turn thinking off. You can also play around with the reasoning effort setting from low to medium all the way to extra high just to control how wordy the model gets. And hey, if you actually have the monster hardware to push past 262,000 tokens, you are going to need to use yarn scaling techniques in your config to handle that ultra-long text effectively. So you might be wondering, why is it worth dealing with all this hardware hassle in the first place? Well, in the OS World Verified Computer Use Test, which basically evaluates agentic multimodal intelligence, Qwen3.8-27B scored an unbelievable 84.3%. To put that into perspective, it absolutely crushed massive cloud models like Opus 4.6 Max, which only managed to hit 72.7%. It is a completely elite reasoning agent, and it literally fits on your desktop. Which leaves us with this final thought to chew on. We just watched an 18-gigabyte local file turn everyday consumer PCs into elite, vision-capable AI agents. When open-source communities can optimize software this incredibly fast, and hardware is hitting these new bandwidth milestones, we really have to ask ourselves, is the era of cloud-only frontier intelligence officially over? Thanks so much for joining me on this explainer, and I will catch you in the next one.